Covalent bond cleavage. We know that all chemical reactions involve the breaking of bond and the formation of new bonds. The breaking of chemical bond, we call it as fission, and there are two types of covalent bond fission or covalent bond cleavage, which is homolytic cleavage and heterolytic cleavage. Homolytic cleavage is the type of bond fission in which the two electrons of the covalent bond are split equally between the two atoms joined by the bond. This type of cleavage occurs in non-polar bond involving two atoms with similar electronegativity. So, to present this type of cleavage, we will be using half-headed arrows because the bonds will break symmetrically. This type of cleavage, also known as homolysis, in which each atom will get one electron, and the resulting species are known as free radicals. This is because free radicals are an atom or group of atoms which contain unpaired valence electron. The free radical, also known as reaction intermediates, which are very reactive and very unstable. The movement of single electron in homolytic cleavage is often shown by a curved half arrow. Next, let's take a look at heterolytic cleavage. Is it a type of bond fission in which the both electrons of the covalent bond remain on one of the atoms. This type of cleavage occurs in polar covalent bond involving unequal sharing of electron pair between two atoms of different electronegativities. For an example, in this case, R is more electronegative than X. So what will happen? The Rx bond will break heterotically, and both of the bonding electrons are transferred to R to form carbocation and also anion. This process is also known as heterolysis, and the heterolytic cleavage will produce positive and negative ions, which is anions and also cations. So what will happen to the two shared electron? The two shared electron will split unequally between the two atoms. So the breaking of bond in heterolytic cleavage can happen in two ways. Okay, the first case is when A is more electronegative than B. So what will happen? Okay, the two electrons will be transferred to A. So A will become anion and B will become cation. And second case is when B is more electronegative than A. So what will happen to the electron? Both of the electrons will be transferred to B to form cation and also anion.